So today we're looking at uh, systems of linear inequalities. Yesterday we did inequalities. Inequalities we graphed very similar. Then you shaded in above or below based on whether it was greater than or less than. You did the dotted lines and the solid lines, those types of things. Now this one here, now we're going to have two inequalities. Kind of like at the beginning when we did, substitution, elimination, those types of things. Okay. This case we just have the inequalities now. The big thing for us is we're just going to do them by graphing. So system of linear inequalities is made up of two or more inequalities. We're only going to be looking at two of them right now. And a solution of a system of linear inequalities is an ordered pair that makes all the inequalities in the system true. Okay, yesterday we did it where you took the point and you plugged it in. If it made the thing true, then it was a solution. In this case here, now we're going to have to put it into two equations if you want to check it that way. Or we're going to solve them by graphing. And I think it'd be pretty easy to see where they fall into then from that. All right, but these definitions really aren't that much different from the equations and from the inequality type things we did yesterday. I'll give you a second to write those down. All right, we good? Dom, you still writing? You good? Okay. All right, so how are we going to solve these guys? Well, we're going to use solve by graphing. All right, this is really going to be the only option we have for this. This is what we're going to use. So what you want to do is you want to graph both inequalities on the same coordinate plane, and the solutions, I should say solutions lie in the overlap section of the graph. So what's going to happen? You're really going to have three shaded in regions. Okay, two of them are only going to have a single shading. The other one's going to have like a double shading. That double shaded region, the one where they both interlock at, that's what I call our overlap section. That is going to be the area of all the solutions that satisfy both of those. Okay, we'll see this in a second. Let you get that written down. Then we're just going to get right to some examples. There's not a whole lot of lead up to this. We're just going to hit some examples now. All right, so I gave you that piece of graph paper, right? Get that thing out. That's what we're going to need. So the first one's going to look like this. Okay, y is less than 2x minus 3, and y is greater than negative 2x plus 2. So we have two inequalities there. We just want to graph both of those on the same coordinate plane. Now there's an additional question there. We'll deal with that in a few minutes. These are the two here that we want to graph. A couple different ways you can do these. I'm going to do these in two different colors because it's on the computer and I have it, and I think it's going to be easier to show you guys. Um, what I would do for you guys, I'll show you here in a second. So let's just graph it. I'll use a few different colors. All right, so the first one, y is less than 2x minus 3. So let's do that one in yellow. So 2x minus 3, I'm at negative 3. My slope is 2, up 2 over 1. And is that going to be a dotted line or a solid line? Dotted. Dotted. Why is it dotted? There we go. There's no equal sign underneath it. All right, so I'm going to go ahead and graph that guy. Looks something like that, correct? Now, it's less than, so do I shade above or below? Can you see that? Sort of. Do I shade above or below? Below. All right, so I'm going to shade over here in this section. Okay? Second one, let's do this in a different color. So let's go, I don't want that. Let's go red for this guy. All right, so this one, y is greater than negative 2x plus 2. So I'm at a positive 2 right there. My slope is negative 2 down 2 over 1. This one would be a dotted line as well, correct? All right, so put a dotted line in here. It's supposed to be straight. It's really tough on us. All right, so there's that line. Now, it's a greater than, so do I shade above or below? I shade above, correct. So this guy, I'm going to shade over here. Now, do you see how I kind of shaded in two different directions? Like I did the yellow go in one direction, the red go in the other direction. All right, it gets really sloppy, but if you look at it, this kind of checkered section right here, this is going to be that overlap section. We all see that? All right, and so if you only have one color, if you're only using a pencil or a pen, if you kind of do that, shade one direction, shade the other direction, I think it shows up pretty nice. If you just kind of scribble, then it becomes a mess. You know what I'm saying? So looking at this one, it's really hard to see still. Your overlap section would be over here. All right, here's our overlap section. It's kind of ugly, but I think you can kind of see. All right, now if we check the point, let's look at the point, 3, 0. So the point 3, 0 would be right there, correct? Is that a solution? Yes, it's in that overlap section, so that one's good. How about 2, 5? We got 2 and 5. It's in one of them, but does it count as a solution for the system then? No, it does not. Questions on that one, guys? Yeah. Is that all we're going to have to do? That's pretty much it, yeah. Anybody questions on that? All right, let's try another one. So this one here, y is greater than negative x plus 5. Y is less than or equal to 3x minus 4. All right, let's do it the same way as we did last time. Graph the first line. Is it going to be solid or dotted? Solid. It's going to be solid because it has an equal sign underneath, correct? Go ahead and graph that. My y-intercept is 5. My slope is negative 1, so it's down 1 over 1. Is it going to be shaded above or below? It's going to be above, correct? Okay, so that guy's shaded. Second one, is it going to be solid line or dotted line? It's going to be solid as well. Okay, I have a y-intercept of negative 4. Slope here is 3. It's up 3 over 1. So it's going to look like that. Now am I shading above or below that one? It'd be below. So it's below on the left or right side here? It'd be on the right side, correct? All right. So that would be here. So where's my overlap section? It's kind of that top right, correct. Be this area up in here. Correct? So Hoover is the 0.43 in a solution. Yes, it is. Diamond is negative 3.1. Is that a solution? No, it's not. SB, how about 4, negative 3? No. Camden, how about 0.1? No. And Dick, how about 6.6? Yeah, it would be. All right. How we feel with this so far? Easy. Easy? That's what I'm hoping. All right. All right. You guys try this one here. Come on. Yeah, this is supposed to be x on this second one. All right, so y is less than 4, and x is less than or equal to -2. So we talked about this yesterday. Anytime we have something like this, what type of lines are they? It's that special case. Yeah, horizontal and vertical lines, right? So first one, y is less than 4. Is that going to be horizontal or vertical? Horizontal, right? It's backwards. It's backwards of what you would think, right? If it's y equals, it's going to be horizontal, even though it feels like your y-axis goes up and down. Okay? So this one here, y is less than 4, so we're at y is 4. This is going to be a dotted line. Okay, it's going to be right there. And then the second one, x is less than or equal to -2. Oh, we didn't shade this, did we? So less than, do we need to go above or below? Below. Okay. Now, second one, x is less than or equal to -2. Is this horizontal or vertical? This is going to be vertical. Let's go blue for this one. Okay. It's going to be a vertical line through x equals -2. Is this solid or dotted? It's going to be solid, correct? Right there. And right there. Now, this is less than, so we can't really shade above or below when it's a vertical line, right? So what did we say yesterday? We treat it like a number line, correct? So if we're less than, are we going to shade on the left or the right? On the left, correct. All right, we'll shade on the left. So now we'll shade this direction. All right, so where's my overlap? Bottom left. Okay, this area right through there. Questions? Happy? Questions? All right, here's one for you guys to try. This has a normal line, and it also has one of those special case lines. So take a few minutes and try that guy. we have two different things. We have one is just kind of a normal line. The other one is one of our special cases, right? So the first one, let's do it in blue. So y is greater than or equal to 2/5 x minus 5. So I start at minus 5, the slope of 2/5, up 2 over 5. You get 7. All right, so we got a straight line. Okay, are we shading above or below? Are you sure? What's this sign say? So greater than or less than? It's not less than. It's greater than, man. It cannot be less than. It's greater than. So it's greater than, so we shade above, correct? Okay. Then the second one, we're going to do that one in red. So y is less than 4. Is this going to be a vertical line or a horizontal line? It's going to be a horizontal line. Okay. Horizontal, be right through here. It's going to be a dotted line. Okay, so it should look like this. And we shading above or below that thing? We're shading below it. So we shade below it. It would be in this area here. Okay, so this is kind of a different one than what we've seen. It would be this area in here, right? That's where a double shaded region is, or overlap. Bless you. Questions on that? Anybody? All right. What happens now if, I'm going to put two different equations here. What happens if I get something like this here? What if I have, let's go 2x plus 2y is greater than or equal to 6, and negative x plus y equal is, go, I'll change that, is less than 3.
Can we try it?
What's the problem here now, first off, before you even get started?
You gotta get y on the right side.
Yeah, you got to get y by itself, right? So the first one, what do I have to do?
You have to
You have to divide, but before you divide, you have to move what?
minus.
Not the 6. Let's move the 2x, right? Oh, yeah. Getting the y by itself. So now I have 2y is greater than or equal to negative 2x plus 6, right? They're not like terms, so you can't combine them. Now what? Divide by? Divide everything by 2. You'd have to do it to every single term. So y is greater than or equal to negative x plus 3. All right, that would be my first equation. Second one, what do I have to do? Just add the x over. So y is less than x plus 3. Something like that.
See, like, how can the x butt in front of the 3? Why can't it stay at the end?
You can if you want to. But everything's in that form, y equals mx plus b, so I like to put the x up. I like to cozy him up to the inequality or the equal sign. Because if I write this on the board, y is less than 3 plus x. If I write down on the board, you're going to go, Mr. Thomas, what the heck's going on? The x is in the wrong spot.
Uh-uh.
I know you guys. You're going to do it.
All you have to do is put 3 for your first number.
You're going to do it. You're going to mess it up. That's why I changed the order. There's 2 up there. Graph them.
Then we just graph these.
Except, it was just.
You look expecting to. You sure?
So this one should be pretty straightforward, right?
Maybe.
So the first one, y is greater than or equal to negative x plus 3. At plus 3, what's my slope? What's my slope? Okay. Negative 1, right? Down 1 over 1. It's going to be a solid line. Looks like that. Okay. Second one. Oh, are we shading above or below?
Above.
Above. Okay, so we got that shaded. Second one. All right, we're at plus 3 again. Slope is 1. This one's going to be a dotted line. Okay, shading above or below? Above or below? Below, okay. So where's my overlap? Top right, okay? This area right through here. Feeling pretty good? Yeah? Okay. Last one, then I'm cutting you loose. Last one, you're going to have to solve this one as well. So, first one is going to be, let's go, 4x plus 2y is greater than 6. And then also 3x minus 6y is greater than or equal to 12. Now, be careful. In the second one, we're going to have to divide by a negative 6. What happens when you divide a inequality by a negative?
The other numbers become negative or positive.
They become negative, and what happens to the sign?
Switch it.
You have to flip it, correct.
I can
All right, we have to solve them both for what letter? Solve them for y. Now, we could graph these by intercepts. We didn't spend much time on that. I like to focus more on graphing them by rule with y equals, so let's go with that. All right, the first one, I'm going to subtract the 4x over, right? So I have 2y is greater than negative 4x plus 6, right? Then I have to divide everything by 2. So I have y is greater than negative 2x plus 3. So you guys all have that as your first one? Okay. Second one, I take the 3x over, so I have negative 6y is greater than or equal to negative 3x plus 12. Now what? Divide everything by negative 6. That makes that just a y. I have to flip the sign. What's negative 3 divided by negative 6? Positive 1/2. And 12 divided by negative 6 is? How about minus 2? There we go. And there would be your second inequality. All right. Did you get some wrong numbers in there? All right. So let's draw this puppy. First one, y is greater than negative 2x plus 3. We're at positive 3. Down 2 over 1. Dotted or solid? How about dotted? Okay, shade above or below? Above. Good. Okay. Second one. This one we're at negative 2. Slope of 1/2, up 1 over 2. Solid or dotted? This one's solid. Okay, shading above or below? Below. So we don't have a whole heck of a lot of overlap, do we? Just this section kind of right here. Now, obviously, we have a limited amount of space on our graphs that does go on forever. So that spot, it's going to, the farther you go out, it's going to get bigger. Okay, and all of this would be part of it. Any questions, guys? Anything at all? Okay, so stop right there.